In calculus, we actually spend a lot of time writing equations of lines. Um, and so I wanted to take a few minutes and review with you the different types of lines and different concepts that one should be familiar with going into calculus, and then kind of apply those to, or just basically review some things you've seen before. So starting with slope-intercept form, that's just standard y equals mx plus b. And most students are fairly familiar with this. So if I give you a slope of 3 and I tell you that it has a y-intercept of 0, 2, in this case you can just automatically jump and put it straight into its linear equation form. So that'd be y equals, the slope is 3x and the y-intercept is 2. Now, the only weakness of that particular method is you have to know the slope and the y-intercept. You have to know that one particular point. Okay. Standard form, ax plus by equals c, and it's got its own set of strengths. Typically, if you're solving a system of equations, standard form is nice. But anyways, an example of this, well, let me go back up to the slope-intercept form. If I bring the y over and bring the 2 over, I get negative 2 equals 3x minus y. And if I just reflect that, then I get it in what typically is our standard form. So standard form is great if you're trying to find intercepts. Then you can plug 0 in for x and 0 in for y and kind of solve. But other than that, doesn't do much. Point slope. Y minus y1 equals m, x minus x1. Okay, now the benefit here is you can pick any point. So let's say I give you the slope again being 3, but let me just tell you that it happens to go through the ordered pair 2, 1. Not just the y-intercept this time, but any other random point. And so I can very quickly get that into point slope form, which is y minus the y-coordinate of the point, which is 1, equals m, so 3 times x minus the x-coordinate of the point. Okay. I'm going to star this. Point slope form will save the day in many a calculus problem. It is a great, a lot of times they'll ask for a linear equation. Point slope form gets the job done. I've seen a lot of calculus students try to get it in slope-intercept form, waste a couple extra minutes solving something for that. And I'm just going to tell you, unless the directions tell you that or your professor says that you need it in slope-intercept, point slope is the way to go. Okay, two other concepts I want to review, and then we'll look at some practice problems. Parallel slope. Okay, the symbol for parallel kind of looks like an 11. It's not really, so that means parallel slope. And the shortcut, or the way to remember parallel, is that it's the same slope as the original slope. So if I give you a slope of 2, the parallel slope would also be 2. If I give you the slope of one line is negative a half, the parallel slope would be also negative a half. Okay, which is why we say parallel slopes are the same. Okay, perpendicular. It looks like an upside down T represents perpendicular. Perpendicular also is another way to say normal. So if you see that in calculus, just remember, oh, he means normal. And your perpendicular slope, the phrase that most students come across is opposite reciprocal. Okay, so if I give you, let me kind of go with these two examples here. If I give you a slope of 2, the perpendicular slope opposite, so positive goes to negative, and 2 goes to 1/2. Okay. If I give you negative 3/4 as a slope, the perpendicular slope to that would be opposite, so negative goes to positive, and 3/4 we flip, and that goes to 4/3, so positive 4/3. Okay, so and then we're going to practice utilizing these different forms, and I want to just emphasize that, again, point slope form is great. It is just awesome. Definitely saves us a lot of time as far as writing equations go. So the idea here is I'm going to give you a condition. We're going to write an equation in point slope form. So let's say I want an equation parallel to 3x plus 2y equals 6. Okay. Well, I need to find the slope off of this, and some of you might know shortcut formulas. I'm one that I got to look it up, in which case it's not a necessarily shortcut if I got to look it up, but I do know how to rewrite it. So if I bring the 3x over, I get 2y equals negative 3x plus 6, and then if I divide everything by 2, I get y equals negative 3 halves x plus 3. Now of this, I just want the slope. So if the slope is negative 3 halves, what's the parallel slope? That would also be 3 halves. So I got a point and I got a slope. I can just write, point being 2, 4, I can just write it in point slope form. So y minus 4 equals negative 3 halves x minus 2. And there's our full equation. Okay. Number 2, if I want the perpendicular equation to this, I want to know what the slope is first, so this already is in slope-intercept form. So I want slope is 1 half, which means the perpendicular slope would be opposite reciprocal, so negative 2. And I have the point it goes through, so that would be y minus a negative 2 equals negative 2 x minus 1. And the only thing I see we can do is the two negatives make a positive. And we could have just done that at the beginning, but that's okay. So y plus 2 equals negative 2 x minus 1 is a perfectly fine equation. Okay, so one more parallel to this equation happens to be in point slope form and goes through this other point. So I just need the slope off of it, and the slope in this equation would be negative 2. So parallel to negative 2 would be negative 2. And then we're going to write the equation through the point negative 1, negative 2. So that's just y plus 2 equals negative 2 x plus 1. Okay. All right, so the last thing that I want to run through is converting back and forth between the different forms, because in calculus at different times it would help to be able to go back and forth if in particular you need it. Okay, so let me start with, let's see, we're given standard form, and we need to go, we need to go into, let's go slope-intercept form first. So if I bring the x over, so negative 2y equals negative x plus 10, and then I divide everything by negative 2, I get y equals positive a half x minus 5. Okay, so there's one of my forms. And then off of this, I can get the slope is a half, and it goes through the point 0, negative 5. And so I can automatically jump to point slope form, which is y minus negative 5. So y plus 5 equals 1 half x. Well, x minus 0, I guess, if we're going to be technical about this. which we can simplify into other forms, but the goal of the exercise was to write it into the two other forms that we have. Okay, number 5, I'm given slope-intercept form. I want to convert to the other two. So I'm going to go ahead and pull off of this that I have a slope of 2/3 and a y-intercept of 0, 5/2, which means I can automatically jump and put it into or point slope form. So y minus 5/2 equals 2/3 x minus 0. All right, then if I want to convert this into standard form, I'm going to clear the fractions first. So I'm going to multiply everything 6 by both sides. And why did I pick 6? Well, the denominators have a 3 and a 2 in it. So I know the least common multiple of 3 and 2 is 6. So if I multiply everything by 6, that'll get rid of any fractions that I have. Okay. So I get 6y equals, let's see, 6, 3 goes into 6 twice. So 4x plus, and 2 goes into 6 3 times, so that'd be 15. And then I can bring over the 15 and bring over the 6y. So negative 15 equals 4x minus 6y. And then I can try that reflecting process. So 4x minus 6y equals negative 15. Okay. And then lastly, let's see. So given point slope form, if I distribute and combine like terms, that'll get into slope-intercept form. So y equals 3x plus 6 plus 2. And all I did was distribute the 3 in, and then I brought the 2 over. So that's y equals 3x plus 8 would be slope-intercept form. And then the only other thing I'm missing is standard form. So if I swap the 8 in the y places, so negative 8 equals 3x minus y, then I can get standard form out of that. Okay, and so the last little point I just want to make here is hopefully in this little exercise you got the impression that point slope form is very powerful and very easy to use. And the other forms aren't terrible, but they did require a little bit more effort on some of this. So please remember that when you look, and this comes up in calculus.